Welcome to Garrett CompSci. This is Code.org's AP Computer Science Principles course. This is Unit 1, Lesson 3, Circle Square Patterns. We start off with this prompt: how many ways can you represent 7, the value 7? Well, we have this digit here, 7. So we can use the Arabic numeral 7. We could write out the word 7 in English or in any other language. So we could use Spanish, for example. We could use tally marks. We could use Roman numerals. So we could do all kinds of things to represent that concept of the value 7. Last lesson, Lesson 2, we discussed the concept of representing information using everyday items in the classroom. So we talked about pencils pointing up or down or in various other directions to represent different values. And we arrived at the idea that it would be easier to use multiple pencils in a series that only either pointed up or down. So 2 options per pencil. And then if we needed more than 2 options, we would just add another pencil each time we needed more. We found out that if we have 2 options per pencil, every time we add another pencil, it doubles the number of options we can make. So building on that same idea, we've got here circle square patterns. So here we've got 3 circles in a row. We've got circle, square, circle. If you were to make all the possible patterns with 3 spaces, and each space can either be a circle or a square, think about how many different patterns you could make. The answer, mathematically, is how many options can you put in each place, that's 2, circle or square, raised to the power of how many places we have, 1, 2, 3. So 2 to the power of 3, or 2 cubed, is 8. 8 patterns. And these 8 patterns that we could make could be mapped to 8 different values, 8 different answers to some question. Very simply, they could be literally the numbers 1, 2, 3, 4, 5, 6, 7, 8. So a pattern like circle, circle, circle could mean 1, or it could mean 0, or it could mean 7, whatever we wanted it to mean. But you can imagine it will matter what the order of our patterns is, so that we can determine what each pattern maps to. What does it mean when we see circle, circle, circle? So, if you were to write out all of your possible patterns, and we compared with other peers in our class, we might not all have the same 7th pattern if we had not come up with the same rules of which pattern comes after which. How do we count in these patterns? So in your activity guide for this lesson, and remember you get those on your Code.org lesson here, and you go to Lesson Resources for the activity guide. I already have that open. And here is a place for you to write down all the possible patterns where each place is either a circle or a square. And challenge 2 asks you to come up with some very specific rules so that you know what comes next in this progression of patterns. And then you later expand those rules to see if it works well when we add another place value, another place for a circle or a square. So we're not going to, on this video, not going to like run through the whole activity. I'm going to show you my rules. So my rules look like this. I'm going to go with circle, 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 square. So notice I've got a square coming in from the right. Okay, now on this right one, for circle, 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 I've put both combinations in this third place. So now I'm going to move to a square there, and we'll start with circle on the right. Now I'm going to say circle, square, and do the other third place, which is a square. And now I'm going to move a square into this first place, the leftmost place, and set both of those back over to circles. And now I'm going to say the other combination that starts with square, circle, ending in a square instead of a circle here. And then I'm going to go square, square, and start again with the circle in that rightmost place. And finally, square, square, square. And as we said earlier, that makes 8 combinations. And so we could make this pattern, circle, 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 mean the information 1. And this means 2, and so on. So if all we had available to us were places to write circles or squares, one or the other, then we could make these patterns to mean the information 1 through 8. Alternatively, we could make this mean 0 through 7 if we wanted to make sure that we were able to represent the value 0. Since there are 8 of them, these could represent our directions on the compass rose with the in-betweens, where this is north, northeast, east, and so on. So these 8 patterns could represent any 8 things, any 8 pieces of information. And what we've done here is we've invented our own number system. We've come up with a pattern of combinations, with a specific order that can mean all the possible values. For example, it can mean all of those numeric values from 1 to 8. So we've come up with a series of patterns, of combinations, that mean a series of numeric values. And that's a number system. Okay, thank you for watching. This was lesson 1.3. Go ahead and hit subscribe if you haven't already, and continue with the next lesson, 1.4, where we move on to binary numbers. Thanks again for watching.